Hi guys, in this video we are going to discuss about AC circuit with inductor based on VTU Belagavi Karnataka. Let us begin AC circuit with pure inductor by considering pure inductor say L. Let us apply AC voltage across this. That is V is equal to Vm sin omega t. Due to the closed path, we expect instantaneous current I. So, when inductor is subjected to alternating voltage, the EMF induces in the inductor, that is called statically induced EMF. That means the EMF induces in the inductor without any physical movement. So, therefore, the induced EMF is called statically induced EMF. This statically induced EMF can be formulated by using the formula VL is equal to minus L into di by dt. This formulated based on Faraday's law. Here, this can be rated that minus V, where V is the applied voltage. This minus sign is indicate that the induced EMF in the inductor opposes the cause of it according to the Lenz's law. Now, let us say V is equal to L into di divided by dt. Now, I want to calculate this current, so therefore I want to take this dt to left hand side, L into left hand side. Therefore, equation has become V dt divided by L is equal to di. Integrate on both sides, then we will get that I is equal to 1 by L. L is a constant, so integration of V dt. Let us apply what is V here, that is V is nothing but Vm sin omega t. Therefore, I is equal to 1 by L integration of, where V is nothing but Vm sin omega t into dt. This is equal to, the Vm is constant, take it outside, then Vm by L. Integration of sin omega t is nothing but minus cos omega t. Here we are integrating with respect to t. Omega is a constant, so therefore divided by omega. This is equal to minus Vm divided by xl cos omega t. So what mean by xl is nothing but it is omega into L. This is called reactance of inductance. So therefore, and the one more point is here, the unit of this impedance is ohm. So then voltage divided by imaginary resistance is nothing but current. Therefore, this can be written as minus Im cos omega t. Let us say this is equation number 1, applied voltage, that is V is equal to Vm sin omega t. And here I cannot compare this instantaneous current with this applied voltage because this is in terms of sine, this is in terms of cos omega t. Let us convert this cos to sine with the help of the trigonometric conversion formulas. As you know that all students take coffee or all silver teacups. In the first quadrant, the angle is 90 minus theta and all are positive. I am using this property to convert it. Therefore, minus Im cos has become sine pi by 2 minus theta, or 90 minus theta. So let us multiply this minus 2 sine term, then it is become Im sine, where theta is nothing but omega t minus pi by 2. So this is equation number 2. By comparing equation number 1, that is V is equal to Vm sin omega t, and I is equal to instantaneous current, I is equal to Im sin omega t minus pi by 2, what we can say that the current is lags by 90 degree in pure inductor. That means in pure inductor, the current I lags voltage by 90 degree or pi by 2 radians. Okay, let us represent this current and voltage and lagging in a phasor diagram. For the phasor diagram, I want to consider upward voltage V as a reference here. So therefore, it's a reference V, and current is lags. The lagging is always indicated by in clockwise direction. So it is perpendicular to the reference voltage, and this is I. The current is lags by 90 degree or pi by 2 radian. Let us see same thing in the waveform. Okay. This is omega t. Along the x-axis, let us consider V. Okay. Upward voltage is a sine wave. So this is called V is equal to Vm sine omega t. And current is lags by 90 degree. This is 0 reference point, or you can call 0, and this is pi, and this is 2 pi, and in between 0 and pi, what you can call this is pi by 2, and the starting point of the current is pi by 2. Okay, so this broken line is what you can say current, that is I is equal to Im sine omega t minus pi by 2. Okay, and let us extend up to this reference point. Okay, so from this waveforms, what we can say, the current is lags by 90 degree. Okay, let us see the simulation part of the pure inductor. Here, the red color is indicate voltage waveform, and the blue color is indicate that the current waveform. From this simulation part, we can clearly see that the current is lags by 90 degree. This simulation is done with the help of multi-sim. Let us calculate the average power, that is P average is equal to 1 divided by 2 pi over complete time period 0 to 2 pi P into d omega t. This is equal to 1 divided by 2 pi 0 to 2 pi, where P is nothing but Vm sine omega t. I is nothing but Im sine omega t minus pi by 2 into d omega t. This is equal to, here Vm Im is constant, take it outside, therefore it is equal to Vm Im divided by 2 pi integration from 0 to 2 pi sine omega t as it is. Sine omega t minus pi by 2 is nothing but it is cos omega t into d omega t. Okay, let us do the integration. Before doing the integrations, I want to do a lot simple modification in this term, that is, so already we know that from the trigonometric formula, sine 2 theta is equal to sine theta 2 times of sine theta cos theta. Okay, so then sine theta into cos theta is nothing but sine 2 theta divided by 2. Okay, so then this equation has become Vm Im divided by 2 pi 0 to 2 pi. This can be written that sine 2 omega t divided by 2 into d omega t. This is equal to Vm Im, take it this 2 into outside, then 2 into 2 4 pi 0 to 2 pi sine 2 omega t into d omega t. Then this is equal to, here Vm Im divided by 4 pi is constant, so integrate this term with respect to d omega t, then it become cos 2 omega t divided by 2. Limits is from 0 to 2 pi. So this equation has become Vm Im 8 pi. Let us substitute the limits here, that is a cos 2 into 2 4 pi minus cos 0, then this is equal to Vm Im divided by 8 pi. Okay, cos 4 pi is nothing but plus 1 because it's even number. Then minus cos 0 is always 1. So 1 minus 1 is 0. So therefore the average power in pure inductor is 0. So it's clearly indicate that the power consumed by pure inductor is 0, but it stores energy in the form of stores energy in the form of electromagnetic field. Okay, but this stored energy can be calculated by using the formula E is equal to 1 by 2 Li square, and it is joules. Okay, this is all about the average power consumed by pure inductor. Let us see in terms of waveforms now. First I want to draw voltage waveform. Okay, let us erase this part. Okay, I will redraw this again. Okay, fine. I will consider only one full cycle, omega t, and this is V. Okay, let us consider current. As you know that current is lags by pi by 2 degree. Okay, fine. I will extend this voltage waveform. So this is V is equal to Vm sin omega t, and this is current. I is equal to Im cos omega t. Then between 0 to pi by 2 instant, the voltage is positive, current is negative. So therefore the whatever the power lobes we're getting there like this. Between pi by 2 to pi, in this instant both are positive, therefore the power lobe is this. Between pi and the next instant, again the current is positive and voltage is negative. So plus into minus is minus, so therefore this is the lobe. And here to the final instant, that is 2 pi instant, both are negative, so minus into minus positive. Okay, let us consider the instant 0 to pi, only half instant here. This half instant, what we can see that the current, the power is negative, lobes what I'm getting here, this power actually it's, yeah, and this is positive lobe. So the average value, even though for the half cycle the power is 0. So this is all about pure inductor in the AC circuit. Thank you for watching.